Hello everyone. In this video, you are going to learn about the principle of moments. And my name is Timothy Muriwa Joseph. I haven't changed my name. Okay. What you will learn include 1. After watching this video, you would be able to define and apply the moments of a force. Number 2, you will know that the weight of a body may be taken as acting at a single point known as its center of gravity. And number 3, state and apply the principle of moment to objects balanced on a single pivot. So this is what you are going to learn in this video. And number 4, you will be able to calculate moments at a given point. And lastly, you would know the conditions for equilibrium. So these are the things you are going to learn in this video. So I will beg you to take your time to watch this video to the end, and then you try to share it so that it can get to more students. Let's begin. Forces and moments. Here we have a spanner and a knot. So spanners are used for tightening and loosening knots, and they help to produce a larger turning effect as one of the examples of levers. So whenever you use a lever or a spanner, you are using a force to turn an object about a pivot. For example, if you use a spanner to loosen a wheel nut on a bicycle, you need to apply a force to the spanner to make it turn about the wheel axle. And then the longer the spanner, the greater the turning effects force. And this turning effect of a force is what we called a moment. Please take note of this. The longer the spanner, the greater the turning effect, which is the force that is being applied to it. The turning effect of that force is called a moment. This is very important for you to understand because this is what we are talking about in this lesson. Moment of a force about a point is given as force times the perpendicular distance from the points. So moments may be described as clockwise or anti-clockwise. And the moment of a force is also called a torque. The moment of a force is also called a torque. Okay. So moment is given as force times the distance from the pivots. Take a look at what is happening here in this picture. Here we can see a man trying to loosen the wheel of his car, or trying to lose, yes, and then he's using a spanner. So here, to increase the force applied to undoing a wheel nut, he needs to extend the length of the spanner, and this can be done by inserting a length of pipe over the end. So don't forget that we say that the longer the spanner, the greater the force. So this man, in order for him to make his work easier, he needs to extend the length of the spanner, but not too long. And he can do this by inserting another pipe or rod into the end of the spanner, and then that will increase the force applied, and then his work will be easier to do. Then he can lose the knots and then gets the wheel out, whether it's losing or tightening it, whatever. Let's look at a few examples of calculations involving moments. Here we have a beam which is 4 meters, that is 4 meters, and a force of 5 Newton is applied to it. So the moment about x, or about point x, is just going to be 5 multiplied by 4, that is, which is the perpendicular distance. Don't forget that we say that moment is given as the force applied and then the perpendicular distance. So we just say multiply 5 by 4, which is 20 Newton, and it is a clockwise direction. Another example, so which is anti-clockwise, we have the perpendicular distance, which is 5, and then a force of 3 newtons is applied to it. The same thing is applicable here, since moment is given as force times distance. So all we need to do is just to multiply the two numbers given to us here. So we say 3 times 5, and we get 15 newtons anti-clockwise, which is in anti-clockwise direction. So let's go to the principle of moments. This is a beam, and this beam is in a state of balance. Yes, it is in a state of balance. In order to be balanced, the clockwise forces must, that is the clockwise forces here, the force here acting here, must be equal to the anti-clockwise forces. This is the anti-clockwise force here. So if another force is applied to it here, maybe to make it balance, so that means we are having a combined forces. So, but here we just have a larger force here, and then here we have a smaller force here, and the beam is in a state of balance, which is uniform. So we say that the beam is in a state of equilibrium. So because it is balanced on the pivots here, so it is in a state of equilibrium. And then that takes us to the principle of moments. So the principle of moments states that if an object is in equilibrium, the sum of the clockwise moments about any point is equal to the sum of the anticlockwise moments about that point. So basically, the principle of moments states that the sum of the clockwise moments is equal to the sum of the anticlockwise moments about a given point. So if an object is in a state of equilibrium, so this is what the principle of moments says. So please try to put this in memory, which is very important. It will help you in calculations of moments. Let's look at some worked examples. This is a beam that is balanced on a pivot at center X, and then our anti-clockwise force that is applied to it is 20 newtons from the center, that is on the pivot, and that's, we have the perpendicular distance here is 1 meter from the pivots, and then we have combined forces here. So we have a force which is applied to it, 5 newtons from the pivot, so the perpendicular distance is 2 meters. So this is our clockwise force that is applied to it here, clockwise moments rather. And then we have another force which is 20 newtons applied to it from the pivots. The perpendicular distance is 0.5 meter. And here, the principle of moment states that the sum of the clockwise moments at a given point is equal to the sum of the anti-clockwise moments at a point. So which means that the force here must be equal to this since this beam is at the state of equilibrium, that is this balance. So let's look at the calculations. Anti-clockwise moments, which is 20. So we say 20, that is taking the moments at this point. So 20 times 1, so we have 20 Newton meter here, and then the same thing here, but here we have combined forces. So we will take the moments at this point and at this point too. So here we have 5 multiplied by 2 here, and then we plus it to this one because we are having combined forces here. So we say 20 times 0.5. So when we do that calculation, so this is going to be 10, and this is also 10 as well. So 10 plus 10, we arrive at 20 Newton meters. So you can see that the forces, the clockwise moment is equal to the one acting at the anti-clockwise moments to make it balance. Okay, so this is very easy to do. So I've just considered a few examples here. I'm going to do another video. I'm going to consider more examples about the principles of movement. I'm going to show you more calculations, calculations. Yes. Thank you for taking your time to watch this video. I'm sure by now you have learned what the principle of movement is, and then you would be able to do some of these simple calculations by yourself without having any problem. So please do like this video, like the page so that you can get more notification when I share video. Also try to share this video so that you can get to more students. I also have more video lessons on my page. Take a look at those videos. You're going to learn a lot, and try to share those videos. They're just free lessons that I'm doing. Thank you. Goodbye. See you again.